In some of my previous videos, I've explained how to use components, including an LED 4-digit display, a relay module, and a keypad input with your Arduino. And in this video, what I want to do is to explain a puzzle that uses those elements together. So how it works is this. On my Arduino, in my code, I've defined a number of 4-digit codes, like pin numbers, for example. And when a player uses the keypad to enter a code here, it's going to be displayed on the LED display to start with. If it matches one of those codes that's been stored on the Arduino, that is going to be used to control one of these 4 relay blocks, either turn it on or off. So I've got a total of 8 codes stored on the Arduino, 2 for each relay, one that turns it on and one that turns it off. And then on this side of the relay, you can have whatever load you want to be powered at all. I've just got a maglock here, which has got a 12-volt supply going into this relay module at the end, and I've left the other 3 open at the moment, but you can have them plugged into whatever you want really to power it all. So let me show you how it works. First of all, if I enter a code that isn't stored on the Arduino, so if I just make one up, so I'll do 3698, you'll see the code comes up, flashes a few times, and then it disappears. 5632, for example. Same again. So those are not codes that are stored in my Arduino. Now, if I enter the code 1001, you'll see there the light came on because that was the code that toggled this relay. And if I do 1000, the code will go off again. So now it's just a matter of me remembering what codes I set to continue the demonstration. So I think 2001 will turn that one on. You can see that the third relay along already had its light lit. So if I do 3000, that's going to turn that one off. And if there are any loads plugged in at this side, these would all be being toggled on. Now relay number 4 is the only one that I've actually got a load plugged into. So 4001 is going to do that and make my maglock clang on the floor. And if I do 4000, that will reset that again, and I can plug that back in. So obviously I've just been using codes like 1000, 1001, 2000, just so I can try to remember them to be able to show you. But they can be absolutely any code you want. In fact, they don't have to be 4-digit codes. They can be any length code you want. I just was using a pin number for sort of convenience. So let me show you the wiring and the code as to how this works. Here's the wiring in fritzing, so I can just show you in a bit more detail. So in the center here I've got an Arduino Uno. Now one thing to note about this project compared to some of the other projects I've shown is that it does require a reasonable number of digital input and output pins. So I'm using an Uno, which is fine, and you could certainly use a Mega or probably some other microprocessors as well, but you might not be able to get away with one of the smaller style boards because you do need to have a reasonable number of input and outputs. So so here I've got my my 4-digit 7-segment display, and this is exactly the same one which I used in one of my earlier videos. So it's got 3.3 voltage in and ground, and then it has 2 data wires, one that carries the clock signal and one that's the data in and out. They're going into the analog pins on this side. They don't actually need analog, they can go into any pins, but that's just for convenience, they're over this side. And then up here I've got my keypad. So again, this is one of the models which I showed in one of my earlier videos. It's a 3x4 style, and it has so 7 wires coming out of it, because it has 1 for each of the columns and 1 for each of the rows, and they are going into pins 7 to 13 on the Arduino on this side. And then down the bottom I've got my 5-volt 4 relay module. So that has got a 5-volt supply, and that has got ground as well, and then it has 4 individual signal wires which are going to control each of the relays being on or off, and those are going into Arduino pins 3, 4, 5 and 6 up the side here. And then on the other side of the relay I have a 12 volt DC input. That's going to my maglock, and then on this side that's wired into the normally closed side of the relay, and then into the common pin here is going to the maglock, so that when the relay switches across, that's going to break the connection or make the connection so that this gets power from the DC input there. Here's the code that's running on the Arduino, and a lot of this is quite similar to the code I've shown before when I was demonstrating each of these components individually. So what I'll do is try to concentrate on the stuff that's unique and different in this puzzle. So to start with, as always, I need to include any libraries that are relied on in this project. So I've got two libraries here, this one which is being used for the LED display, and this one that's being used for the keypad. The display library is not included with the Arduino installation by default, but you can download it from this GitHub link here. The keypad library you can install directly just through the Arduino IDE by going to the Manage Libraries menu. And those are the same libraries as I've used before. I always start off by defining a conditional debug statement here, just so that when I'm debugging the puzzle I can send some more information out to the serial connection, but when you actually sort of release the puzzle into the wild and you're using it in production, you don't need to have all that extra debugging stuff going on unless you need it. So for now I'll leave that defined just so that you can plug a USB serial connection in and get some information on the monitor, but that doesn't need to be in production. So to start with, I now define first of all the definition to go with the keypad. I'm using a 3x4 matrix, and that's the layout of the keys on my keypad. So it's 4 rows and 3 columns in the array there. And these are the pins on the Arduino. Remember from the wiring diagram that the row pinouts are going to, and these are the ones that the column pinouts are going to. So that just defines the pins there. And these are constants because they're not going to change at all throughout the duration of the code, so we define them as constants. These are the 4 pins that each of the modules in the relay block are going to. And then here I define the 2 pins that are used by the display. So the clock pin is going into A0 and the data pin is going to A1. So that's just defining the pins, which you can see on the wiring diagram anyway. Okay, so we then create some global objects. So here we create the keypad object. That's the main class from the keypad library, and that's what we're going to be using to capture what digit was pressed on the keypad. And here we define the display library. So here we've got just the keys that we defined above, and here we have the keys and the pins that we defined above as well. Okay, so now I'm going to define a data array, and it's an array of char characters, and to start with I've just put in 4 spaces here. So this is going to be the variable that records the input that has currently been made by the player. Now I've defined it as a character array of chars, because although I've talked about pin numbers and 4-digit numbers, and that's probably what you anticipate the solution to be, notice that my keypad did have a hash and an asterisk key, and one of the other keypads I showed in my last video also had the letters A, B, C, D as well. So if you want to be able to use keypads that have non-numeric input in the code as well, you couldn't define this purely as an int number or anything like that. You need to be able to capture those non-numeric characters as well. So that's why I've defined it as an array of chars instead. And I've just put sort of 4 blanks just to show that that is by the start. It is effectively an empty string. You can think of that. Okay. And then as the player enters the characters in the code one at a time, what they're going to do is they're going to type the first character, then the second, then the third, then the fourth. And then if that's not right, it's going to start again on the next code, first character, and keep on looping around. So this sequence number here is just a counter that's going to loop through the code over and over until it recognises a 4-digit character. So that's just going to help us control the input. Okay, so what this function does here, so this update display, So remember up here I said that I had data. So this is a character array, and that stores in code what the player has entered that we're going to compare to the true values that we want to do stuff. But it might be the case that the display, or the data rather exactly as entered, can't be displayed on the LED 4-digit display. Remember, each of those digits in the display has only got 7 segments. Now that can give you the digits 0 to 9, and it can also give you the letters A, B, C, D, E and F, and some other letters as well, but it can't display every letter on that code. So what update display does is that it creates effectively kind of like a display ready version of that 4-character code that's been entered. So we can't send the character array directly to the LED display because it might contain, for example, the hash or the asterisk key, and neither of them can be very easily displayed on a 7-segment display. So what we'll do is we'll loop over each of the values in the data array, that char array. Now, if the values are a digit between 0 and 9, we can send that value directly to the display using the encode digit in the right position. So we're looping over the character array. If the character is a number, or if it's technically a character representation of a number, that's why I've got the little speech marks there, we're going to encode that digit. Now what does this minus 48 bit here do? This is a bit complicated. So because I'm storing my numbers as a character array, this isn't actually the number 0 and the number 9. This is the character 0 and the character 9 as if they've been typed on a keyboard. And Arduino stores characters using an ASCII referencing system. And in the ASCII referencing system, the numbers start at character 49. So I'm taking 48 off whatever the ASCII value is of a number, and then I'm encoding that. So it's a little bit tricky to get your head around, but what that's basically saying is if it's a number 0 to 9, we can send it direct to the display, but we're going to take 48 off it just so we're actually looking up the correct value from the ASCII table. Okay. If the data is an asterisk, now remember that I said that you can't display asterisks directly on the 7-digit display. So for that, what I'm doing is I'm just writing to the segment of the display that's the horizontal line along the middle. I explained this this format here in my earlier videos on LED displays, but these numbers here represent each of the individual segments on the display that can be turned on. So this is segment A, B, C, D, E, F and G. So this is just turning on segment G, which is the horizontal line along the middle, and that's what I'm going to use to represent an asterisk. And here we have a hash symbol, and for that one I'm turning on segments A, not B or C, and D. And those are the 2 horizontal lines at the top and the bottom of the display. And then finally, so once I've got my sort of display ready version of the data, we're going to send that to the display. Okay. So it's a little bit complicated, that function, but all that's basically saying is that we're storing and comparing a value that might not be directly suitable for use on the display. So this converts the data we've got stored into a display ready format. That's all it's saying. So flash display, remember I said if you entered an incorrect code, what I'm going to do is to simply flash the display on and off a few times just to warn the user that that wasn't right. So this is quite simple in comparison. Again, I'm defining another 4-digit array that represents the values of each digit in the 4-digit display. But this time I'm just defining them all as 0. So what that's going to do is set all of the segments off. And then just a simple loop that's going to loop over 4 times. It's going to wait a quarter of a second, set all the segments off, then it's going to wait another quarter of a second, and then it's going to display the value back on again. It's going to loop through that 4 times in total. So that's my display to flash when the incorrect value has been entered. So here's the setup function when the code first runs, and this is very straightforward. If we are, oh, that's incorrect, sorry, I've just spotted a mistake. That was meant to say debug. So if we have defined debug mode, we'll start the serial connection up because that's the only thing we'll actually be using it for. We'll turn the brightness of the display to a sort of a mid value, and we'll initialize the relay output pins. We don't need to explicitly set the pin mode for the keypad or the LED display because that will be handled for us by the constructor functions that were at the top of the code. So where we created our keypad and we passed the row and column pins and we created the display with the clock and data pins, that constructor there will take responsibility for setting the right mode on those pins already, so we don't need to worry about that. Okay, and now we get onto the main program loop, and this is the last function in the code. So this is where it all happens. So the first thing we're going to do is we're going to ask that keypad class to give us whatever key was pressed in this frame of the function, and we'll store that in a character called key. Now, if key returns true, that means that a key has been pressed, any key. We don't really care what it was at this point. I've just realised that same mistake there as well. I think I must have done a search and replace at some point and got that incorrect. So if any key has been pressed, we'll just log out to the console what it was if we're in debugging mode. And then what we'll do is we'll set the value of the data array to the key that was pressed. That's the current sequence number. So sequence number starts at 0. So the first time we go through this loop and a key is pressed, we're going to set the first value in the data array to the key. We'll then increment this, so the next time a key is pressed, we'll be setting the second value in the data array, and then the third, and then the fourth, etc. And that will carry on until we have a total of 4 values in the sequence. So we know that the player has entered 4 key inputs in a row to get a 4-digit code. We'll just update the display in between as well. When they've entered all 4 digits in a sequence, we'll throw out to the serial monitor, what the code was if we're debugging. And then what we're going to do, this is where we define what we're going to do based on what code was entered. So this is where you'll want to edit and put in both the code that you want to do something and also what you want to happen when that code is entered. So I've put this as a big if, else, if ladder at the moment. There's other ways you could structure this code, but I actually think this is the easiest way to see what's going on. So we'll start at the top, and this strcomp function, this is a string compare. So it compares that 4-character array that the user entered, and it compares it to the string 1000. And if that's equal to 0, that means there's no differences between them, basically. So that means that whole line there means has the player entered the code 1000? Okay? And if they have, what we're going to do is we're going to set the first relay pin to high, and then we're just going to wait 2 seconds. And then after that, you'll see, okay, well, if that wasn't true, we'll fall on to the next condition. We'll test this instead. So, okay, has the player entered the code 1001 instead? If they have, we'll set the first relay pin to low, and then we'll wait 2 seconds. And then after that, you can probably see that it's pretty much a kind of just a recurring pattern. So 1000 will set the first relay high, 1001 sets it low, 2000 will set the first relay high, 2001 will set it low, 3000 will set the next relay high, 3001 sets it low, 4000, 4001 are high and low for the final relay. If we get to this bit down the bottom here, so this is the bottom of our sort of else-if ladder, and so far none of these have been true. So we've got all the way down. We know that the player has entered a 4-digit code that's stored in data, but it hasn't matched any of these, so we know that it must be an incorrect code instead. And that's when we're going to call the flash display function. And then the final thing we're going to do is, because we've taken whatever action we need to take based on the code that the player was entered, so we're now going to clear out the data array. So we're going to blank the character array that we know that they've written, and we're going to reset the sequence number to 0 again. So that's going to start at the beginning of the next code that they can enter instead. And for the last time, we just update the display again to reflect the current value of data. And that's it. So there you have it. It's a pretty convenient prop to have in your toolset, to be honest, because it can be used in lots of different situations. Keypads like this you might find used to sort of access a door panel, or if you're sort of hacking a terminal, or maybe defusing a bomb or something like that. They're very common. Lots of different escape room type puzzles would use a keypad input like this. And then because this relay here can literally power any load of tool you want on the other side, you can open a door to another area, or you could open some sort of cupboard or chest container, power a light, anything you want. So I hope you find that useful and think of some interesting ways to use it in your rooms. And thanks very much for watching.